Hi, welcome back, you all. Today we're continuing with this design. Let's get to it. At this point, you can pretty much consider this portion done. I had to figure out the actual mechanism for the rail, how it works inside. And for now, I decided to have this bit over here stick out this far. I basically aligned it with the what I consider to be a default position, which is consistent with medium-sized hand. If I discover that this range of motion is not enough, because it would basically be somewhere here, it's not a big deal because I designed it in such a way that you can very easily extend it pretty much as far as you need. Like, yeah, it's just whatever floats your boat, basically. The next stage would be figuring out these channels for the ribbon cables that go from the finger columns, as I'm calling them. This piece over here, I made it for the previous designs. It works fantastic. And the purpose that it serves is it adds tenting to fingers, which puts your wrist in a lot more ergonomic position. But what's really clever about it is that normally the way tension is accomplished with ergonomic keyboards is that you literally angle the entire keyboard. So if I duplicate it a few times, let's add a rectangular array for this purpose. Let's say this is our more conventional type of keyboard. So the way you would add tension is like this. You would just angle it, and this way your wrist would be in a lot more natural position. You would be twisting your wrist a lot less. So lots of ergonomics benefits from this. But the problem is that now I would have to have a lot more sophisticated mechanism underneath if I want to keep them joined with 2 screws each, and if I want it to be possible for them to move independently. And it was really important for me to keep this design rather simple. So you see I have one flat chassis that supports all these. And I printed out several test options. I tried rotating the whole section, as I just showed before. It actually doesn't make a huge difference if these are angled or flat. So this way, that part gives me more ergonomic tension-like feature without actually having to rotate it. So that was a long explanation, but hopefully you get the idea. And what I'm changing right now in this design is that before, this part was independent from this part. So basically the controller box and these shrouds was one piece and this was another piece. And I designed them in here such that when you assemble them, they interlock with one another. And the reason why I really like this is because that gave me flexibility to have this piece and this piece to be printed in different colors. But after making this test render, I figured that I don't care all that much about that particular aspect. I don't mind this, and this to be the same color, or the fingers is irrelevant, but I don't mind this, and this being the same color as it's shown right now, which means that I can join them all together and basically have a lot more rigid design. So that's exactly what I'm doing. I took that part that I already have and I'm just joining them through simple Boolean operation. And the only free tail, so to speak, is the pinky finger channel for the cable, because this column actually doesn't have that razor. It sits right on the main base of the controller. The way I have these fingers designed is that they can actually slide over and interlock with the shroud. And I already tested it. There's plenty of rigidity in here. These pieces are, they have plenty of material in here. So the next step is to just join these together, double Q, and then join these. Oh, and by the way, you don't just simply join these, because you see I have this portion stick out over here. So the way I connect these two, I cut this part with this part first. So the way I do this is I use Boolean operation, but I keep the cutter, and then I manually, I forgot that one last piece, but I manually delete these pieces. And now I can connect them nice and clean. And this piece needs to be addressed independently, exactly the same way. So I cut it, I keep the cutter, I join these two, and I delete that piece that I just cut out. And then from here, I just manually cut out these portions, either by extending it, or if that doesn't work for some reason in a more complex geometry like here, I can just create a separate tool that I could use to cut out a channel for it. And now from here, I can move on to designing the insides of this main body or controller box. So this is, as of now, final design of this part. So it's one large piece, which combined together with the base should have even more rigidity than it had before. Not that it was lacking, but I really dislike when keyboards, squeak and bend and produce any kind of noise as you use them. So I always pay a lot of attention to having as much rigidity. I really like that solid feel to these devices. At this point, I already have all the tolerances figured out. I even tried slicing it in the 3D printer slicer to make sure that I can reasonably print something like this. So this piece should take under 3 hours to print with the quality settings that I'm satisfied with. The next step would be to design the insides, as I mentioned. I need to plan ahead of time how I will be soldering these and how I want to route all these cables, because there's going to be a lot. So pretty much every cutout over here would have 5 wire bundles coming out, and they would have to go into this board, and then this board connects them, and then wires would go from here to this board. And if you watch the very first design video where I was debating what way I should be positioning them, I actually think that something like this would work really well. The only thing that I needed to pay close attention to is to make sure that nothing in here would overlap with the palm rest and its parts. And I made sure that this is the case. So if we do the section analysis, you can see that I have plenty of room for wires everywhere, and these boards don't interfere with any of the parts. There will be a lot of cables going under this board, and they will probably enter either here or go underneath and enter through the back. I'll see what's the most convenient way to solder these. And then from this board, the wires will go into this board. There are obviously 2 outliers, or there is one more ribbon cable that will go from here straight into this board. I made sure that I assigned pins right here in this corner. Basically, wires from the display would go into this corner, and wires from the thumbstick, I don't actually remember. I think they will go somewhere here. I need to double check that, but I think it will end up somewhere in this area. I'm also considering where I will be adding the sound deadening foam. So I think there will be a piece over here, maybe a little bit in between, and definitely a lot over here. I usually cut out a hole for these channels, for these supports to come through. And I will have to leave this part of the chamber mostly empty, because again, this whole piece is meant to move. So this is the range in which it will be able to move, and I need to make sure that nothing gets jammed in here. One last bit that I haven't mentioned yet, at least in this video, is this portion over here. So as I mentioned before, this is my RGB LED, which dictates the semi-vertical orientation of this board. And I'm planning to make a cutout over here so the light from that LED can reach and illuminate this portion of the controller. And as a user looking from above, you'll be able to see it as if this controller had a proper backlight. I am thinking to make it a little bit more interesting than just the box cutout. So I think I'll make it probably follow this shape over here. So probably something like this. I haven't decided yet, but I'll try to make sure that's somewhat aesthetically pleasing.